Hello everyone, this is Manish here. So in today's video, we'll cover some of the most essential data structures and algorithm concepts in one Python program. And we'll look at stacks, queues, linked list, sorting, searching, recursion techniques, all at one place in the single program. So let's dive right into it. So the first program that you see on my screen is on the stack implementation. So we start by creating a stack class using the Python's list. And a stack basically works on the LIFO principle, that is last in, first out data structures. So as you can see at line number 3, we have defined a constructor in it to initialize the respective stack. And over here, if you can see, we have defined the respective stack over here in this case. And from line 6 to 10, that you see that we're performing the push and pop operation. Push generally we use it to add respective elements, and pop is generally to remove the respective elements. And if you see in the respective implementation, what we are trying to do is push is just going to append the respective values, and pop is nothing but it will check if the respective value is not empty, then it is going to pop out the respective values. Okay, else it is going to respectively print stack is empty. Okay, so you can see the is empty function that we have defined is just checking the length of stack. If it is 0, it means it is empty. Okay, so that's about stack. I'm talking about queue. Now in the queue implementation, it follows the FIFO principle. So FIFO basically means first in, first out principle. So here Python use the collection DQ to create the effective queue. So we use NQ and DQ methods to add and remove elements. So DQ allows efficient removal from both ends, perfect for a queue. Okay. So we'll see the respective information over here. So you're seeing the respective constructor being defined over here, and that is how we are using the NQ and DQ, which we currently mentioned right now. Okay. Now, if you see the linked list operation in the linked list that you see in the respective program that you see, so if you see, the first thing that we're seeing is the singly linked list that we have. So each node contains some data and a reference to the next node. Okay, so you can think that generally a list is going to have two respective information as part of that node. The first is the respective value. The second is the reference or the address that is going to store. So generally it stores the reference to the next node. So the node class represents the individual node from line 29 to 35 that you see, and from line 38 to 46 that you see, the list class allow us to insert elements at the head and print all the nodes in the sequence. So this is but powerful data structure compared to respective application. So it looks like the basic, but it is very powerful in terms of handling your respective applications. Now, the next thing that we're coming up, so these are the data structure that we've seen. The next thing that we want to see one of the search algorithm, and when you'll see one of the sorting algorithm as well. So searching basically we'll see this is a binary search. So it basically how exactly it works is it works by repeatedly dividing a sorted list into half. So binary search function performs the search efficiently, and if, the time complexity for it is O of log n. Okay, so making it extremely fast for the larger data sets. Okay, so if you see the respective algorithm over here, in this case, what we are seeing is we have defined low, high, and the length of the array -1, and we are just checking if the low is less than or equal to high. We have defined a midpoint, and we're checking if my midpoint is a target, return the mid. If my midpoint is less than my target, then I'm incrementing my low point, otherwise I'm decrementing my high point. This is how we are narrowing it down for my search element, and in case if the elements even at last is not being identified, we'll be returning -1. So remember one thing, binary search always works on a sorted list. Now, the next thing that we're going to take up is the quicksort algorithm. So quicksort is one of the fastest sorting algorithm using recursion that we generally do. So this quicksort function selects if you see in the respective code here. So in the quicksort, what we are seeing is it basically selects a pivot and divides the list into smaller parts. So this technique uses n log n average time complexity, making it ideal for the large data set in our case. So here you can see we have taken a pivot and divided the respective length of array by 2, and we have taken basically um, the uh, the respective operation that we have used, x for x in array if x is less than pivot, and similarly for middle we have said if x for x in array if x is equal to pivot, and right is x for x in array if x is greater than pivot. And we're returning the, so if you see over here at line number 78, what we are doing is you are using the recursion technique over here. Means the same function is being applied to the left values again, plus middle plus your right. So what you're doing, you're sorting the leftmost all the nodes, all the elements from the list, and the same thing from respective right node for the element. So remember, this is what the quicksort algorithm basically deals with. Now, talking about recursion that we were just seeing. So recursion is nothing but something that you want to do again and again, and we are not using any loop over here. So we're using the functions itself that we are going to call. Okay. So recursion allow us to solve complex problems easily and also handling the infinite loops in our case. Okay. For example, one of the basic program that we generally see is in the factorial. So if you see, we have given n as a respective input to the respective function over here, factorial. If n is equal to 0 or n is equal to 1, will return 1, else n into factorial of n minus 1. So it will keep on happening until the n value reaches to 0 or 1, and that is how the whole value is going to be returned um, uh, as a whole total value in this case. Now, if you see in the line number 87, this is my name is equal to main. So basically my program starts over here. It will print the stack operation. It will call the stack respective construct over here. The object is getting created over here. And this, by using the respective object stack dot push, I'm pushing 10 and 20 in my stack, and I'm using a pop. So what would the pop operation do generally? As you know, this is based on the LIFO principle. It is going to pop out 20. Okay. Similarly, in our queue operation, if you see, we have given NQ, DQ respective values over here. So if you see in our case, what we are doing is, in after adding 1 and 2, once we remove the respective elements, as you know that queues basically work on FIFO principle. So the one that value that got inserted first will come out first. So one gets dequeued from the queue. Now talking about the linked list operation, okay, so we have created again linked list, and we have inserted the value at head as 5 and 10, and this is what you generally see. So remember, the last node that you have will not refer to any respective value because it doesn't has at the end. So that is the reason you are seeing the reference as to none in this case. Okay, now see, for the binary search, I've given the respective list as 1, 3, 5, 7, 9, 11, and my target is 5. So the same function which we discussed right now is being called, and it will print the respective target element is found at which index. Okay. But if you see binary search, the respective arrays are sorted in here. So we'll discuss other algorithms as we move ahead. In case if it is not sorted, how do we search? And similarly for sorting also we have different algorithms. So now for quick sort, what we said is, in the same case, if you see, it is unsorted array, and once it is going to be sorted by using the quick sort technique which we just said. And for the recursive function, what we see is recursive factorial method we have given n is equal to 5, so it will give you 5 into 4 into 3 into 2 based on into 1. That is when the loop will come out of it, and it will return 120 as the respective value, as you can see. So this was just on the high level on the data structures and algorithm that we have. So we'll dig in deep more into it as we move ahead into the later sessions. So thanks everyone for tracking and giving me support to make these videos ahead. I really appreciate it, and please do like the video and subscribe to the channel if you're new. Thanks everyone. Bye.